Hi, today we're going to learn about scientific notation. So we've been learning about exponent rules up to this point. Scientific notation does use exponents, but not exponent rules. So it's going to be something different than what we've been doing before. So here was the bell work that we had today, word problems. And although they look like lots of words and big numbers, all it is we're deciding are we adding, subtracting, multiplying, or dividing. That's all. Approximately, and these are true, I looked these up, 3,504,000 people live in Utah. Approximately 39,430,000 people live in California. If a fourth of the population of California moves to Utah, after the move, how many more people will live in California than in Utah? Okay, so we have a little bit of math to do. First, we have to decide, are we going to add, subtract, multiply, or divide? Well, I need to know what is a fourth of the population of California. Of means multiply. So there was our first one. So we're going to take that population of California. I'm going to use my calculator because I can't do this in my head. If you can do it in your head, amazing. Good for you. 39,430,000. Of means multiply, and I care about a fourth. So 1/4. Enter. All right, let's see where the zeros are. I got 9,857,500 people. So 9 million people are moving to Utah from California. That's not a real thing. I made that number up. I made up the 1/4 thing. But wow, that would be a lot of people moving to Utah. So now that 9 million number I just got from California, they've all moved to Utah. So what do I do to figure out how many people now live in Utah in this pretend situation, right? Well, my 9 million, I'm going to combine it with my 3 million already living in Utah. So I'm just going to add. I'm going to take the number in my calculator. I'm just literally going to click the plus button and add what I have here, 3,504,000. And I end up with 13,361,500. I'm not done though. It didn't ask how many people now live in Utah. It asked how many more people would live in California, because guess what? More people still live in California than live in Utah. So right now, what we have is Utah, like after this imaginary move, we have 13,361,500 people, now imaginary, living in Utah. Well, in California, we got to figure out how many people live there now. In this imaginary situation, we started with 39 million and 9 million of those people moved. So we're going to take I'm pointing at the screen, you can't see that, I can use this. We're going to take our original California population and take away or subtract the amount of people who left, which was that 9 million number. So in my calculator, let's see, I should write this down so I can remember it before it disappears off my calculator. 9,857,500. Commas are very nice to help me know how to say these. So now in my calculator, I'm doing 39,430,000. Take away these imaginary people who moved to Utah, 9,857,500. And now in California, there are 29,572,500 people. There's some commas that belong in there. Okay, all we've been doing is adding or subtracting. Oh, what did we also do? We did some multiplying in there also somewhere. Our last step, how many more people live in California than in Utah in this imaginary situation? Well, we know that more people live in California. That's just like saying I brought in 3 cookies to class, and one of the students brought in 10 cookies to class. How many more cookies did that person bring than me? We can just subtract. 10 minus 3 is 7. That person brought 7 more than me. So we can just subtract these two numbers to figure out how many more people live in California, would live in this imaginary situation, right? The only things that were real is I looked up this many people do live in Utah and this many people do live in California. All right, here's our, and then, you do that subtraction. The mass of the largest planet, Jupiter, so Jupiter, is approximately, and I looked this up, I do not know how to say that number though, but I did look up that number, however you say it. The mass of the Earth is approximately, however you say that number is what it is approximately. Approximately how many times would we fit the Earth into Jupiter? So like we got Jupiter, And then we got the Earth. Woohoo! How many times? So it's kind of like I'm taking Jupiter and splitting it up into chunks that are the size of the Earth. So in your calculator, you'll take Jupiter, and I'm going to just tell you how to do it. You can do it on your own. You're going to take Jupiter, type that in, and then splitting up, that's divide, by the size of the Earth, and then click enter, and that'll tell you how many times we could fit the Earth into Jupiter. Now, our goal, I can write numbers in scientific notation. This is going to be on page 13. There's a reason I did those word problems, and that is because scientific notation helps us take big numbers and write them not so big. Write them in more of a condensed form. So here are some examples. 100,000 million billion trillion, 31 trillion, 27 billion, and a bunch of zeros. Well, what we do is there's an invisible decimal point here at the end. Like, it always exists there, we just don't write it because there's no decimal after that, so we don't need to. To write scientific notation, we need to get that decimal so there's only one digit to the left of it. Everything else is to the right, okay? So I'm gonna move it, and while I move it, I'm gonna count how many times I moved it to get it so there's only one digit in front of it. So I moved once. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I had to move it 13 times to get it right here where I wanted it. So now that I've moved it 13 times, I end up with the number 3.1027, 1027, and then all the rest are zeros, 0, 0, 0, 0, 0, 0, 0. And because it's a decimal, I don't have to write just zeros. Like, I did have to write this 0 because there were numbers after it, but because there's no numbers after this, I don't have to write all those zeros. Now, I'm not actually allowed to ignore the fact that this is a giant number and this is 3.1. You know, that's a very different number than 31 trillion. So our scientific notation just means like, hey, let us know how many times you moved that decimal point. So times 10 to the power of how many times we moved the decimal point. Because when you multiply by 10, all you're doing is moving a decimal point, right? And so this is just saying, tell us how many times to move it to get to that number, that giant number. So here's a smaller one, a little easier to think about. 4,500. Our invisible decimal point will move 1, 2, 3, because I only want one digit in front. And I forgot to mention 0 doesn't count as a digit in front in this case. I'll show you why in the next example. So now I just have the number 4.5. I could write 0, 0, but like, because there's no zeros after it, I don't need to. So 4.5 times 10 to the power of, how many times did we move the decimal? 1, 2, 3, 3 times. Now we have a itty bitty teeny weeny number. I don't know how to say that number. We could figure it out, but I don't know. This is when I say a 0 does not count, because there's already a 0 to the left of the decimal point. I want a digit between 1 and 9 though. So I need to move this so that there's a digit between 1 and 9. Well, so far I've been moving it to the left. Well, if I move this to the left, I only have zeros there. So I now need to move it to the right until I get a digit that is not 0. Okay, if I leave it here, to the left is still just a 0. So I gotta move it one more time. And now I've got 7.31 times 10 to the power of, how many times did I move it? 1, 2, 3, 4, 5, 6, 7, 8. But I cannot just leave it like this, because 10 to the power of 8 means do a giant number where I had to move the decimal 8 times in this giant number. But I did an itty bitty teeny weeny number. Do you remember when we were learning about exponent rules, the negative exponent meant change it to a fraction? Well, fractions are like the same thing as decimals. So what we do is we create this as a negative exponent, because it means, hey, go the opposite direction. When you're moving that decimal, go the opposite way than we were going before. So it's a negative exponent. So here, 1, 2, 3, 4, 5, it's just the number 8. There's nothing after it. I don't even have to put 0.0. Times 10 to the power of, I moved it 5 times, but if I put a positive 5, that means a big number. So I put a negative 5, it means a decimal. So now we do some practice, still on page 13, I believe. And we move it into change it between, I didn't mention this, standard notation, that vocabulary is what we call normal numbers. 27, 1, 13. Those are standard notation numbers. Scientific notation is where you're shrinking this so it's not so big. So invisible decimal, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, I gotta scoot my hand over a little bit. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 7.73. Everything after it's a 0, so I don't have to write it. Times 10 to the power of 19. Positive means big number. Yep, it's a big number. Okay, I love going the opposite way. Type it in your calculator. Then you're done, okay? If you type it in your calculator, then it gives you the answer to go the opposite direction. But I will show you there are times when the number's too big for your calculator, and so you'll type it in the calculator and it won't solve it for you. So I'll just show you how you would do it in case you get a number that's too big. I know I need to move my decimal 6 times, and because it's positive, I know I need to make the number a big number, so I'm going to move it 1, 2, 3, 4, 5, 6. And what do I fill all these blank spaces in with? Zeros. So 5, 2, 0, 0, 0, 0, 0. Let's do it. 5, 2, 1, 2, 3, 4, 5. So 5,200,000. All right, some small ones. 0 doesn't count as the digit to the left. 1, 2, 3, 4, 5. 3.6 times 10 to the 5. Now, 5 would mean a big number. It's got to be negative 5. Okay, this one, again, you could just type it in your calculator, enter, it'll tell you the answer. But if you get a number that's too big, your calculator can't handle it, here's how you do it. I'm going to start over here because I know it's about to happen. My invisible decimal's right there. Well, 8 spaces, but negative means make it a really small number. So I have to move the opposite direction that I have been moving. So 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So I fill in zeros here. Notice how 8 times does not mean 8 zeros. 1, 2, 3, 4, 5, 6, 7. In this case, there's only 7 zeros. So be careful of that. All right. More about scientific notation is word problems, and this is page 14. And you worked with a team on page 14 to help you solve word problems. So here we are. This is page 13. I can solve problems. I can change. Oh, there it was. I can change numbers between standard and scientific notation. Standard notation is a normal number. Scientific notation is a decimal with a single digit in front of the decimal point times 10 to the power of an exponent. Here's the examples we already did. Here's the practice we already did. And here's page 14. I can solve word problems using scientific notation. Let's write down our goal. I can solve word problems using or involving scientific notation. All right, and really it's like one giant word problem that I just broke up into little pieces. The mass of the Earth is that big. True, I looked it up. The mass of the moon is that big. True, I looked it up. This exponent is 24. This exponent is 22. 24 means I'm moving that decimal way more times, which means it's a bigger number. So the Earth is bigger than the moon, as we would expect. Okay? What is the combined mass? Combined means putting them together. Add them together. So in your calculator, you could literally type 5.97 times 10 to the 24 plus symbol 7.35 times 10 to the 22, enter, or equal sign, and that'll tell you. So when it says combine or total or anything like that, we add. Okay, how much larger is the Earth than the moon? That was kind of my example of I brought in 3 cookies and somebody else brought in 10 cookies. How many more cookies did they bring in? They brought in 7 more. I subtracted. So I would do that with the Earth and the moon. I can literally, just like up here, I can literally type in my calculator 5.97 times 10 to the 24 minus 7.35 times 10 to the 22, enter. So how much larger is subtract? Now, in 8th grade, with scientific notation word problems, the most important 2 types of word problems are numbers 2 and 3. And they're very tricky because they sound very similar. How much larger, how much greater, how much smaller, all of those mean subtract. How many times larger, how many times greater, how many times smaller means divide. So that was our example from the bell work, where we had Jupiter and we said how many times could the Earth fit into Jupiter. So it's like having this giant Jupiter and then we're splitting it up into chunks that are the size of the Earth. Well, we're doing that again now. How many times larger is the Earth than the moon? That's like saying, hey, here's the Earth. How many times can I fit the moon inside the Earth? So I'm taking the Earth and splitting it up into chunks that are the size of the moon. So I'm going to divide. This is the one time you cannot just type it in the calculator the way I've done before. If you use the divide symbol right here, order of operations messes the whole thing up. But the shortcut I do is, instead of using the divide symbol, I click the fraction button first. Fraction button. And that gives me the option, it does this. And then I just type the Earth on top, 5.97 times 10 to the 24, and the moon on the bottom, 7.35 times 10 to the 22. That's how we solve the problem of order of operations, is by using that fraction button. Because remember, fraction button just means divide. That's all it means. So when it has how many times, that actually means divide. Okay? Those are the two we're going to focus on when we do some more practice tomorrow. If the Earth rotates this fast, how far does it rotate in this many hours? So that's just saying, like, every single hour over and over and over again, it's going this fast. I think I looked that up. I don't know. I don't remember. Okay. But every single hour. Well, repeated addition, I mean, I could literally just take this number and add it. Plus, 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 plus this many times. But the faster way is to multiply. And so I can literally just type in my calculator, 1 times 10 to the third times 3.2 times 10 squared equals. So anything that's repeated addition means multiply. We deal with that a lot less in scientific notation. It's really like our big, big, big focus is subtract or divide. Sometimes we do some adding in there too. Okay, oopsies. And then we specifically talk, right? We talked about this already. Question 3, dividing instead of subtracting. And then the exit ticket. It's the same exit ticket as the bell work, but now I've changed the numbers into scientific notation. So instead of those giant numbers you had to deal with at the beginning, do you remember how big those were? I didn't even know how to pronounce them because they were so big. It's the same thing. It just now you know how to use short numbers. So I'm not going to go over those because you already know how to solve them. So that's what we learned about today. Have a great day.